Look closely at the African dwarf frog. You might wonder how it survives, drifting through the water with splayed limbs, struggling against the mildest currents. Yet this little amphibian is built for a long haul. It will spend its entire 15-year lifespan fully submerged under the surface. Which brings us to a rather glaring biological contradiction. Despite living exclusively underwater, it does not have gills. It relies on lungs to breathe. This means its most immediate threat in captivity isn't a predator. It is the very real danger of drowning inside its own aquatic home if it cannot reach the air. Because of this lung-based biology, setting up their aquarium requires a strict architectural approach. When it comes to their habitat, water depth is the enemy. This diagram outlines ideal dimensions. You need a 10-gallon tank, but shape dictates survival. It must be short and wide, not tall and narrow. A vertical swim over 12 inches for air requires immense exertion, and that commute can become fatal. And because they make these desperate dashes to the surface for air, they frequently carry enough momentum to hop right over the glass. A heavy, completely secure lid is non-negotiable. Keeping the water shallow and locking the top are your first, most crucial lines of defense in supporting an animal that lives underwater but breathes air. Once you solve the breathing problem, you run into the next hurdle. The African dwarf frog is practically blind and will easily miss a piece of food dropped directly in front of its face. So how exactly does a visually impaired, clumsy creature survive as a successful micropredator? The answer lies in a biological sensory network known as the lateral line system. Looking at this cross-section, sensory nodes run down the frog's flank. They detect microscopic changes in water pressure and vibrations, bypassing sight. This array acts as underwater sonar, tracking exact prey movements in pitch darkness. What looks at first like bumbling incompetence is the behavior of a finely tuned assassin. It simply prioritizes feeling the water over seeing it. Powering this high-performance hunting system requires a specific carnivorous diet. Standard fish flakes will not work here. You need to provide regular feedings of meaty proteins. Frozen brine shrimp and dapnia offer exactly the kind of fuel their bodies require. But there is a massive environmental catch. Their hunting metabolism is completely dependent on the temperature of the water. As this gauge illustrates, they require a strict temperature window locked between 72 and 78 degrees Fahrenheit. Dropping below 72 degrees shuts down their metabolism and halts their drive to hunt. Spiking above 78 degrees leaves them highly susceptible to fatal bacterial infections. Temperature stability provides the actual power for the frog's biological operating system. Without it, the entire predatory engine shuts down. Even with a perfectly fueled sonar system, these micro-hunters possess incredibly fragile physical armor. Unlike many of their aquatic tank mates, these frogs are completely scaleless. Their skin is highly porous, exceptionally delicate, and easily compromised. Because of this structure, they absorb chemicals directly from their surroundings and are easily injured by minor physical abrasions. This vulnerability dictates a strict rule for your aquarium substrate: absolutely no sharp or jacket gravel. The only acceptable ground covers are ultra-smooth fine sand or a completely bare-bottom tank. Anything else invites deadly skin tears and fatal blockages if swallowed. To protect this predator, the floor of its tank must be engineered to be completely frictionless. That porous skin also restricts their water parameters. The environment must remain perfectly stable, with a pH locked between 6.5 and 7.8. This presents a mechanical challenge. Powerful filtration systems are a dual threat. They cause toxic stress, and the strong currents disrupt the still waters required for their lateral line sonar to work. The ideal gear solution is a gentle sponge filter. It cleans the water thoroughly without generating chaotic flow. Finally, we have to address their psychological reality. As small, blind, and vulnerable creatures, wide-open spaces trigger chronic stress. You need to dedicate at least 20% of the tank's footprint to dense, leafy plants and shaded hiding spots where they can safely decompress. Success with this species comes down to respecting its contradictory biology. When you protect that fragile skin, shorten the commute for air, and fuel the sonar, you're left with a resilient and active aquatic companion. To get the exact dimensions and a complete step-by-step equipment guide for building this specific setup, visit tankzen.com.